Hi all, you all are welcome for the Mooney Viscosity practice questions and answering sessions. So in my last video, I uploaded several questions regarding Mooney Viscosity, and today I'm going to discuss the answers for those questions. So in my question list, the first question was to plot Mooney curves for following rubber types. So here you may all see there are 5 different types of rubbers are given here: unfractioned unbleached grape rubber, fraction bleached grape rubber, yellow fraction, and technically specified rubber. Finally, the ribbed smoked sheet rubber. So here are the abbreviations. So before going for answering this question, we will see some pictures of these rubbers. So this one is for fraction bleach grape rubber. It is white in color. So here you can see unfraction unbleached grape rubber. So it is yellow in color. This is the yellow fraction rubber. So it is more dark yellow in color. So it is a very hard rubber, so we will see some detailed descriptions on these rubbers later. So you can see here RSS, which is kind of sheet rubber. So actually this is smoked and honey brown in color, and this one is technically specified rubber, TSR. So these are called block rubbers. So these are mainly made from the field coagula. So the hardness, the stiffness of these rubbers are very much less compared to these types of rubbers. So we will see what is the composition of these rubber. Before that, I want to tell you that natural rubber has two main components. The first component is the rubber component, that is basically 1,4-cis polyisoprene polymer. Since the natural rubber is a natural product that we are taking from the Hevia brasiliensis trees, it contains non-rubbers, means the materials that cannot be considered as cis polyisoprene. So these non-rubber components are protein, lipid, metal ions, moisture, etc. So different types of non-rubbers are there. So these non-rubbers can affect the Mooney viscosity. We know the Mooney viscosity is basically governed by the molecular weight of the rubber, but it is known that these non-rubbers, for example proteins, can mainly affect for the Mooney viscosity of natural rubber types. So we'll see how these non-rubbers and the rubber component affect the Mooney viscosity. So first I would like to take the yellow fraction. So this is a very hard rubber. It contains more non-rubbers, proteins for example. So those are tiny particles, so they can increase the stiffness or the hardness of this rubber. So compared to other types of rubber, the yellow fraction contains somewhat less amount of rubber, because these yellow fraction grape rubbers are mainly made from the skim latex and the fraction which is taken from the fraction bleach grape rubber manufacturing process. Normally the average Mooney viscosity of this YF range from 85 to 105. Then we'll go to the unfractioned unbleached grape rubber. So this contains somewhat more amount of non-rubbers, but compared to the yellow fraction this can be low, but in comparison to fraction bleached grape rubber, the unfractioned unbleached grape rubber has somewhat high Mooney viscosity. So you can see the average range of UB's Mooney viscosity. So friction bleach crepe rubber, the non-rubbers are removed during the process, so we call that process as fractionation. So the non-rubber content of this rubber type is very less. So compared to unfraction unbleach, the FB rubber gives somewhat lower average Mooney viscosity values from 70 to 80, like that. Then come to the RSS. So this is basically same to the rubber and non-rubber composition of unfraction unbleached crepe rubber, but this is a type of sheet rubber which is smoked during the process. So this also has somewhat high Mooney viscosity values. Sometimes it can exceed the Mooney viscosity of unfraction unbleached crepe rubber. You can see the average Mooney viscosity that ranges from 75 to 99. And technically specified rubber, finally. So I told that it is made from the field coagula. So we apply high temperatures, high cutting and shearing actions during the manufacturing of TSR. So normally molecular weight will reduce, and therefore those should show lower Mooney viscosity values. So normally it ranges from 60 to 65 Mooney units. Okay, based on this information, we can see the yellow fraction has the highest Mooney viscosity value, then RSS, then non-fraction unbleached crepe rubber, then fraction bleached crepe rubber, finally the technically specified rubber. So this should be the model answer for this question. We can see the Mooney viscosity in the y-axis in Mooney units. Here the time in x-axis measured in minutes. So yellow fraction has high initial torque value, then RSS, thirdly the unfraction unbleached crepe rubber, fourthly fraction bleached crepe rubber, and finally TSR. So that is how the initial torque of Mooney viscosity has been changed against these rubbers. So now we know the basic or the typical shape of the Mooney viscosity curve. Mooney viscosity ends at the 5th minute because we normally measure the Mooney viscosity in 4 minutes testing time at 100 Celsius temperature. So yellow fraction has shown the highest value, then RSS, then non-fraction unbleached crepe rubber, then fourthly the fraction bleached crepe rubber, then technically specified rubber. So the previous table gives the reason for this variation. So this should be the model answer for the question 1. Okay, we will see the answers for the next 4 questions. Okay, these are the questions. So we need to draw the potential Mooney viscosity curve for B and C compounds compared to compound A. Okay, we'll see what are these compounds first. So there are several compounds from A to G, and here are the composition of these compounds. If we take one for example, the compound A contains 100 parts of rubber, zinc oxide 5 parts, stearic acid 2 parts, processing oil and carbon black. They are not available in the compound A. So what is the unit of measuring these amounts? Here 100, 5, 2, here different, you can see different amounts are there. So these amounts are measured in parts per 100 parts of rubber by weight, that is called PHR. So we use this PHR as the unit of measuring the amounts of materials in the rubber formulations. So here you can see, if we take for example the compound G, so here you can see there are 100 parts of rubber. For that it contains 5 parts of zinc oxide, 2 parts of stearic acid, and 2 parts of processing oil, finally 60 parts of carbon black. Like that we can read the formulation. Okay, now the first question is to compare these three compounds. We need to compare B and C with respect to the compound A. So how do we determine the Mooney viscosity of these three compounds? The only difference among these three compounds is the amount of processing oil. A doesn't contain processing oil, B contains processing oil at 1 pHr loading level, and C contains 2 pHr of processing oil. Okay, the basic principle we have to keep in our mind is once we include oils to rubber compounds, it reduces the viscosity value. Means when we increase the amount of processing oil in the compounds, it reduces the Mooney viscosity value. So then we will see the answer. So here you can see the graph X, here mole units, and here is the time. So here the compound A, B and C. So A is the compound where no oil is available in that compound. B contains 1 part of or the 1 pHr of processing oil, so the viscosity of B should be lower than the compound A. And in the C compound it contains more processing oil, that is 2 pHr shows. Therefore the C compound should show the lowest Mooney viscosity value. And also this affect for the initial torque also. So the same pattern can be seen here. Now we have to compare the D and E with A. Now we know the composition of A. We'll see what are the difference between A, D and E. Rubber, zinc oxide, stearic acid amounts are same. The only difference is the D and E compounds contains carbon black. Actually carbon black is a kind of filling material that we are used in rubber compounds. So these are called fillers. Actually the carbon black can increase the failure properties of rubber. It can increase the stiffness, it can increase the hardness of rubber. Means once we incorporate carbon black like particulate or the powder form fillers into rubber compounds, it increases the compound's hardness. So in other way, the carbon black like fillers can increase the viscosity. So we have to keep in mind, once the particulate materials like fillers are added to rubber compounds, they can increase the viscosity of the compounds. So then based on that fact, here the A compound doesn't contain carbon black, so it should show the lowest viscosity, and D contains 30, so it should show somewhat high viscosity value compared to A, and the highest Mooney viscosity value should be shown by the compound D. We'll see the answer. So in the plot Y you can see the compound A, which doesn't contain any kind of particulate fillers, here the carbon black, so it has shown the lowest Mooney viscosity value. And the compound D contains 30 pHr and E contains 60 pHr of carbon black. So here the D compound contains 30, so it has shown somewhat higher viscosity value compared to A. The E compound contains the highest carbon black amount, that is 60 pHr, so the compound E has shown the highest Mooney viscosity here. And also it has effect to the initial torque of these Mooney viscosity curves in the same way. Okay, we will see the third question. Here we have to compare F and G with A. So these are the F and G compounds. We know about the A, then we'll see what are the difference between F and G. The F and G compounds contain processing oil 1 and 2 as well as 60 pHr of carbon black in each of these. Okay, the compound A doesn't contain carbon black, so it should show the lowest Mooney viscosity value. And F and G contains 60 pHr of carbon black in each, so since the particulate fillers like carbon black increase the viscosity of the compounds once they are incorporated in the compounds, so these two compounds should show high Mooney viscosity values compared to A. But what is the difference between F and G? The F contains 1 pHr of processing oil and G contains 2 pHr of processing oil. We know once we incorporate oil materials, that reduces the viscosity value. So then which compound from F and G will reduce the viscosity value in higher amount? We know that when we increase the oil-like materials, they reduce the Mooney viscosity value more. Based on that fact, the G compound should show lower Mooney viscosity compared to F. We'll go to the curve Z. Here you can see the A compound doesn't contain carbon black, so it should show the lowest Mooney viscosity value. Compared to A, F and G contains 60 pHr of carbon black. Since the particulate fillers increase the viscosity, the F and G should show high Mooney viscosity value compared to A. So it is represented here. Between F and G, the G contains 2 pHr of oil compared to F, where the F contains 1 pHr of processing oil. So more oils will reduce the Mooney viscosity value in higher amount. Since the G contains high amount of oil, it should show lower Mooney viscosity value compared to F. So we can see it here, and the F contains less amount of processing oil, so Mooney viscosity of compound F should be high compared to the compound G. So same pattern can be seen for the initial talk of these three Mooney viscosity curve. Okay, we'll see the final question. We need to compare F and G with E. We need to compare these three compounds. We'll see the difference. Rubber is same, zinc oxide amount is same, stearic acid content is same, and the carbon black content is same. The only difference is E doesn't contain processing oil, but F and G contains processing oil, where the F contains 1 pHr of processing oil and G contains 2 pHr of processing oil. We'll see the curve first. The plot Z dash shows the answer for this question. So we know the E compound doesn't contain processing oil, but F and G contains processing oil. All of these three compounds contain 60 pHr of carbon black. So the amount of filler cannot affect for these Mooney viscosity curves, but the processing oil content can affect for the Mooney viscosity of these three compounds. Here the E doesn't contain processing oil, so it should show high Mooney viscosity value. Compared to that, the F contains 1 pHr of processing oil and it should show less amount of Mooney viscosity compared to E, since the oils reduce the Mooney viscosity of rubber compounds. Compared to both of these, the highest amount of processing oil is there in the G compound, that is 2 pHr. So the lowest Mooney viscosity should be shown by the compound G. Okay, This is how we can predict the results of Mooney viscosity by looking at the compound formulation. The basic things you have to keep in your mind are the viscosity of the rubber compounds can be increased by the addition of particulate fillers, and the viscosity of the compounds can be reduced by adding oils to the compounds. So if we know both facts, we can predict these type we can predict the variation of Mooney viscosity curves by looking at their composition of the compounds. And there are several other things to learn. We will discuss them in future videos. I hope you will get something from my video. Please subscribe the channel. Thank you very much.